Hey class. Per Jason's request in seminar the other night, there were a couple of problems that I worked through, a couple of examples in the seminar that were especially challenging, and they were actually towards the end of the hour. So Jason had said, could you just send out a video? So this is one of the questions, and realize that it's actually not identical because I didn't want to do the exact same question, but it's similar to it. So hopefully you can see it on the screen, and it says, suppose you randomly select a family with 4 children. Now on your actual example, I think you're going to see that it has like 3 children maybe or something smaller. So this example is actually harder, I think, than what you should see. But hopefully by watching me go through this, you'll be able to figure out how to do the one that's in your actual homework and that's possibly going to be covered on the quiz next week in Unit 8. Assume that births of boys and girls are equally likely. Find the probability that the family has children according to the qualifications. So you're really going to be answering 5 different parts to this question. This is a multiple event type of question because you're not just having one child. If you were having one child, then it would be easy to figure out the probability of getting a boy baby, and that would be 50% or 0.5, or finding the probability of getting a girl baby, 0.5 or 50%. That's easy because there's just one child. But when you have multiple children, then you have to look at the combined probabilities of the different outcomes. So one of the ways that I think it may seem tedious at first, but it's really a fairly easy way of making sure that you come up with all the outcomes. And that's what I was showing in the seminar the other night. So in this case, there's 4 children. That means I'm going to do the numbers 1 for the first baby, 2 for the second baby, 3 for the third baby, and 4 for the fourth baby. Well, the first baby, this is called a tree diagram because it looks at branches of possible things that can happen. Tree diagram. They're really common in courses on probability and stuff like that. All right, and in decision trees that businesses use and so forth. So your first baby underneath the 1 here, that stands for your first baby, can either be a boy or a girl. So you just put a B or a G for boy or girl. Then you move on to the second child, but you look at the possibilities of the second child based on what possibly happened with the first child. So that means you begin to form your branches. So the second child, let's suppose the first child was a boy. Well, the second child could either be a boy or a girl. So notice I'm branching it off the assumption that the first baby was a boy. But suppose the first baby had been a girl. Then I need to branch off the G and make the second baby be either a boy or a girl. And then same thing with the third baby and fourth baby. So you just keep the branches going off of each previous outcome. So boy, girl here. Branch this one out. Boy, girl here. So while this may seem tedious, in the long run, it's actually going to be a pretty assured way of making sure you don't miss out on any outcomes. And it also makes it easier to answer all 5 of the questions pretty quickly. So the time-consuming part is just getting the diagram done. So BG, BG all the way down. And then the last one, same thing. I'm kind of running out of room. Now, you won't take up as much space because y'all are not going to have to do 4 children. Yours is going to be smaller. Your tree diagram will not be as big as this. So I'm just continuing with all these boy or girl possible outcomes all the way down. Now, one of the things that this does is allows me to easily write out all of the outcomes. Now, there's going to be a bunch here, but you won't have as many on your actual example. So I'm just writing all the BGs, BGs, BGs all the way down. BGs. Okay. You'll be able to tell how old I am with that comment. All right. So B and G. Okay. So there are a lot of outcomes here. And the way you start listing them is you just start going through the tree diagram. Like, for example, the first outcome is B, 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 and B. That would mean that the 4 babies are all boys. So you write down the B, 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 and then you keep going through B, 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 G, until you've gone all the way down the list. So this is time consuming because, like I said, there are 4 children. Yours should not take quite as long as this. So B, 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 G, and then across again, B, B, G, B, until you notice you're going straight down here and not missing anything. So B, B, G, B. Sorry, this mouse is kind of hard to write with on this program. All right, B, B, G, B. And then B, B, G, G. And then BG, and again, I'm just following straight through. BG, BB. I already got this one right up here. And BG, so BG, BG. So if you were doing this without a diagram, it would be a lot harder to keep track of all the outcomes. It would be very easy to miss some, in other words, if you didn't have some sort of structured way of going through this. All right, now I'm right here, B, G, G, G. Already done all those. So now I'm moving down to the second half. Now notice so far I have 8 outcomes. I'm going to have another 8 from this bottom section. So I'm now going G, B, B, B. I'm just going to put those over here because I'm running out of room. G, B, B, B. G, B, B, G. G, B, G, B. And again, if you're wondering where I'm getting these, I'm going straight through it. G, B, G, B, right there now. And then G, B, G, G. And then this lower piece, G, G, B, B. And y'all, normally I would be a lot faster. This mouse is really hard to write with on using this program. So I apologize that it's taken so long. You're probably like, heck no, I'm just going to skip that problem. But y'all don't skip it. It's really not hard. This is the only tedious part. And then I got G, G, B, G. And almost done. G, 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 B. And G, 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 G. All right. So really, there are a total of 16 outcomes. That's going to be important because remember, in probability calculations, the bottom number, the denominator, is always the total number of equally likely outcomes. I mean, think about it. When you roll a die, your denominator is a 6 because there's 6 equally likely outcomes on a fair die. So that's going to be important. Now, you will not get 16 when you only have 3 kids. It'll be a number lower than that, and you'll be able to figure that out with your tree diagram. All right, so here we go with our answers, and should be a lot quicker than doing the tree diagram. First question, find the probability that 4 children are of the same gender. Well, that only means that the family was either all 4 boys, same gender, or all 4 girls. So when you look down at your outcomes, you should realize that that's only this outcome or this outcome. So the answer to part A is that there are 2 possible ways you can get 4 children of the same gender out of the 16, but of course you would then reduce that to 1/8. That's your answer to part A. Part B, find the probability that you get 3 girls and a boy. Now notice that doesn't specify order. So what I have to do is look at all 16 outcomes and find how many, no matter what order, have 3 G's and 1 B. That would stand for the 3 girls and the boy. So I'm going to just check them off. 3 G's and 1 B. And let's see where we see those. 3 G's and 1 B. And I think it's only, let's see, that one. There's 3 G's and 1 B there. Let me make sure I'm not missing anything. All right, yep, and I think that's it. That all the other ones have, more than 1 B in them. So 3 G's and 1 B means there's only 2 ways that can happen. Out of 16, again, there's another 1/8. Find the probability that you get a girl a boy, a girl, and a boy in that order, though. So that's got to be in this exact order. A girl, a boy, a girl, and a boy. So let's see how many of those we see. Has to start with a G. So I'm going to come over here to this side. GB, GB. Well, there's one of them right there, GB, GB. But as you keep looking down, that's the only one. So the answer to part C is there's only one way that can happen out of 16 total possible outcomes when you have 4 children. Part D, find the probability of getting at least one girl. Now realize the words at least mean that or more. Like if I say I want you to get at least a 90 in my class, I mean a 90 or higher, not lower. So at least one girl means we're going to go find the outcomes that have at least one G or maybe even more than that. And there should be a bunch here. So I'm just going to go check them off, pick a different color. So all the ones that have at least one girl. Well, this one, because I see at least one G. This one, I see a G. There's going to be a bunch. I see at least one G. I see at least one G. I see at least one G. And actually, all of them except for the 4 boys have at least one girl. Logically makes sense. So the answer there is 15 out of 16 is your probability. That's the chance of getting at least one girl, because there's only one possibility that's not at least one girl, and that was the BBBB. And then lastly, find the probability of getting at least 2 girls. Well, that means I have to look for all of the outcomes that have at least 2 or more G's in them, at least 2 girls. So let me go through, let me pick a different color and I'll check those off. At least 2 G's. So I'm going down this first column over here. This one has at least 2 G's. I'll put a red check. This one has at least 2 girls. I'll put a red check. At least 2 girls. At least 2 girls, in fact, more than that. So put a check there. At least 2 girls is here. At least 2 girls is here. At least 2, in fact, more there. At least 2 here. At least 2. At least 2, in fact, more there. And at least 2, in fact, more here. So I'm going to count all those red checks. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 red checks. So that would be 11 out of 16 for that final answer. I think I got that right. 12, 13, 14, 15. Yep, 11 checks. So that's how you do this. It's a pretty tough problem, but certainly if you just tried to off the top of your head figure this out, that would be very hard to get these correct because you would have nothing structured to look at and to go by. This is probably one of the more structured ways of figuring out the answer to that question in your homework. And like I said, even though it was tedious at first, you won't have as many as 4 children, so it won't take you quite as long. And once you go through that tedious part, it should be pretty easy to answer the actual questions. So I hope that is helpful for you on getting, you should know when you get to this question on the homework because it's worded very similarly to this. It just won't be 4 children. I think it will probably be 3 children or something even lower than that. So hope that's helpful for y'all.